Over the past 6 months, we've been working to perform a data migration for a multinational engineering firm to move their requirements from IBM Doors to an alternative platform. If you're not native to the engineering space, requirements are essentially complex pieces of documentation that record anything from planning to execution, testing, and results in a hierarchical, searchable format. This migration involved moving 87 unique projects, which contained over 1.5 million individual records, and these records had nearly a million relationships between one another. In addition, there were over 3 million fields unpacked from a data store specializing in highly structured data types. Functionally, we can break down this project into three main stages: pre-migration activities, the migration, and post-migration activities. For the owners of the data, the pre-migration stage is the most intensive aspect of a migration. This is because moving data between platforms can be seen as a fresh start or a soft reset, and many decisions have to be made to normalize the data and prepare it for the new platform. During this phase, we took on the responsibility to standardize the process, which involved creating templates and processes to aid in the capture of the decisions made by the customer. Since the conclusion of the project, we have updated this architecture to better fit industrial scale. The process begins by defining the item types that exist within the new platform. All modules will eventually fall under one of these item types, and some common examples of these are customer requirements, system requirements, or a set of test cases. Once the item types are defined, we must perform a mapping of all modules from the source platform to the new platform. The pre-migration toolkit allows us to programmatically create a custom workbook that can be completed via a workshop with an expert. This workbook serves as the ground truth for the migration toolkit, dictating how each module will be mapped. With the module mapping ground truth available, we begin working on reformatting the field mappings. The field mapping stage is perhaps the most important and time-consuming aspect of the pre-migration process. Many modules utilize their own set of custom fields, and these custom fields frequently overlapped and occasionally even caused data type conflicts. We discovered that it was necessary to resolve all of these conflicts up front, otherwise we risked meltdowns in the pipeline or delayed and damaged data. After the project closed, we noticed it took a huge amount of time to implement these configurations utilizing the web interface, especially with the increased scrutiny we were giving to fields and pick lists. So, we built a tool utilizing the API and our customer workbooks to automatically configure item types, projects, fields, and pick lists, turning a set of tasks that could take 2 weeks into one that takes 2 hours. Right now, the toolkit has been built for IBM Doors, but the core services are completely modular. So, if a set of input data differs, we are able to build a normalization harness and connect to the core services of the toolkit, reducing some of the overhead of starting a new platform. Let's talk about the core migration activities. This period was the most intensive for our team. We divided the customer data into a series of sprints and assigned each team member around half a dozen projects per sprint. These sprints took anywhere between 3 and 4 weeks, and once completed, the projects would exit the pipeline verified and ready for customer validation. During this project, we were provided a template toolset that hooked into the IBM Doors platform called MTS, short for the Migration Tool Suite. This toolkit generated many of the artifacts we needed and facilitated the import of records by utilizing the RecIF data format. We quickly began iterating on this toolkit so that it could perform at an industrial scale. We made a lot of changes along the way, but some of our most important optimizations were utilizing the input files to systematically populate item type, migration status, and field information, automatically packing complex fields that would otherwise corrupt data during migration, and finally, detecting instances of corruption in the packed data, and repairing it before import, saving thousands of records that were silently failing. There is still a significant amount of room to improve this toolset, how we use it, and our process in general. But this reflection has been the catalyst for many of the changes that can be seen in the pre and post migration activities. The final stage of the project was post migration activities. Once the data arrives, our final job is to unpack it and verify it. I want to stop and highlight what we mean when we say the word unpacking. When we migrate records, we store a significant amount of data within a JSON file, and all of this data needs to land in the right place. This is unpacking. The value of the pre-migration toolkit reaches its apex during the unpacking step. We are able to utilize the pre-existing mappings to create an unpacking schema that is generated and executed with minimal input from any team member. Moving this mapping to a programmatic step reduces the risk of errors and saves many engineering hours because all of the decisions come from a single source of truth. Another important aspect of post-migration is verification, because sometimes tools break, servers go down during a script, and sometimes there are edge cases that none of us have seen before. In our pilot stage, we were utilizing a semi-manual process that involved generating reports and comparing them utilizing spreadsheets. This worked for 50,000 records, but doesn't scale to millions very well. This is why we created the automatic verification loop. It utilizes the API to build a local tree of the project, then references the single source of truth database to investigate any instances where the legacy data isn't unpacked. After the full tree has been explored, unpacking jobs are created and executed. The verification loop then checks the nodes that were flagged to determine if those records were repaired or if they need human intervention. This iterative process can save hundreds of hours, isolating only the most extreme edge cases for intervention. We recognized early on the importance of communicating the status of these migrations effectively. So, we built a reporting suite that can generate our unpacking records in either an Excel or PDF format, helpful for both our internal teams when we're reviewing projects or during status meetings with the customer. If you have any questions about our technology services at INVENSITY, please reach out and connect with me or one of my teammates on LinkedIn.